All right, so let me preface this video by saying that I'm going to be talking about how I go about solving algebraic equations. But that being said, a lot of the necessary skills for solving algebraic equations are related to simplifying algebraic expressions. Now, I already covered my approach to that stuff in a different video, so this is going to be just talking about the things that are specific to solving equations. Namely, the manipulation of equations in order to pursue the isolation of a variable. So the main things that I see happens to students are two main things. One is improper use of the manipulation actions, and the other is just general disorganization and messiness. Now, I'm sure every teacher has their own strategy for dealing with organization, so I'm not going to go too much into how I approach this kind of stuff. I'm just going to demonstrate it. But the main stuff that I'm going to be concerning myself with in this video are in dealing with student misconceptions and errors regarding the improper use of to both sides actions. One that happens right from the get-go is that they just forget to do it to both sides. They only do it to one side. You have to remind them that they have to do it also to the other side. A second one, once they get into multi-step equations, they start doing both actions to a single side. Now, there are a couple different reasons why this might happen, but mainly it's because they end up getting too formulaic in their approach and they fail to see other options for a first step besides adding or subtracting to both sides. And when they have like terms on the same side, they usually end up subtracting twice from them, even if they're on the same side of the equation. And then in general, they just get frozen sometimes when they're encountering things that that they aren't familiar with. So they have a reluctance to execute a manipulation action unless there is a term to receive it. So this is particularly true with addition and subtraction. If the goal is to move one term from one side of the equation to the other, they can't accomplish it because they don't perceive it in that way if there's not a term on the other side already to add or subtract from. And then once we get into multiplying and dividing, this one happens so often. Once we get into multiplication or division steps that happen before the last step, because in the formula it's always this is the last step. But if there is a case in which they're trying to do it before the last step, they don't multiply or divide all the terms in the equation. They only do it to one specific term on either side. And you can see why they might see that as fair and equal if they're doing it to one term on either side. But of course, that we as mathematicians know that that won't work. That doesn't get the job done. So what do I do about it? So the first couple things I do are just specifically related to vocabulary. If you've watched my other Rogue Math stuff, you notice that vocabulary is a big part of how I approach these things. Very specific with the way in which I talk about these skills. So I don't talk about adding or subtracting to both sides. Instead, rather than talking about it in terms of an operation, I talk about it as adding a new term to both sides. And the reason why I really pursue this is because I want them to feel like they are creating a new thing on either side rather than making an alteration to existing things. And that way they feel comfortable just adding and subtracting things willy-nilly without having to have a receptacle already there to receive the operation. And then the other specific vocabulary has to do with the multiplying and dividing. Instead of saying multiply and divide both sides, I say multiply and divide all terms. I also included a brand new action to add to the list of possible manipulative actions. This action I call the commutative property of equations, which makes it fit right in with the addition property of equations and the multiplication property of equations. I will talk about this more on the next slide, but for now, just know that it's something that I have added to my curriculum. And then finally, I try and de-emphasize the formulaic approach in favor of concentrating on the rules and uses of each of these manipulative actions. And I try and make the students comfortable with executing them in a variety of scenarios. So oftentimes we just end up practicing executing these manipulations, even if it's not leading us um, to the goal of isolating the variable. We just do it, just to see what happens. And so I do a lot of this, like, let's see what happens if we do blah to an equation. All right, so as far as organizational structure and my action vocabulary, I usually have my students divide the area under the equal sign, just like so. Then we have a clear left side of the equation and right side of the equation. I teach them about the two goals and remind them of these two goals frequently. The end goal is to find the value of the variable. The process goal is how we accomplish the end goal, and the process goal is isolating the variable. So I always try and get them to have both goals in mind because this is what they're actively trying to accomplish with the end result of being able to do this. Um, I reinforce this. I call it cake layering approach to writing underneath the equation. I call it action, rebuild, and actually use the visualization of a cake with cake and then icing and then cake and then icing to help them visualize that process. And of course, I forbid them from doing any operations in that area. So I pretty much reinforce that this is only for recording the manipulations and their outcomes. That action, rebuild, action, rebuild. If they need to do some vertical addition or subtraction or multiplication or division, they're doing it off to the side. They're not doing it in this space. This space is being kept neat and clean. So just to demonstrate how this might look, if I'm going through this two-step equation, I'm doing plus 8 to both sides. So that's my action, and then I'm getting my result of 50. This is my rebuild, and then my next action goes below that. Divide both sides by 5, and I should say divide both terms by 5, and then finally I have my final rebuild at the bottom. All right, finally, the commutative property of equations. If you already know the commutative property, all I'm doing is I'm extending the existing definition of the commutative property to include terms moving across the equation. Um, and this can be used as an alternative to adding new terms to both sides. So it's an alternative way of getting your terms moved around the equation to prep them for combining like terms. I find that once students get into multi-step and variables on both sides, a lot of students really latch on to this way of doing it as opposed to the adding new terms, which makes sense because it can often be seen as faster and more intuitive. Um, so verbatim, I would say that I introduced the commutative property of equations as a term that moves to the opposite side of an equation must also change its polarity to the opposite side. And I also use the mnemonic switch side, switch sign. So if a student is forgetting to do this, in their process and trying to accomplish it instead of the other property, then I'll just remind them switch side, switch sign, and that really latches into their brain. Finally, in practice, what does this look like if I'm doing it in practice? Well, you could organize vertically or you can organize horizontally. I found uses for either. Personally, I do vertical organization, but when I'm teaching, I often use horizontal organization because it's neater. But if I'm doing my vertical organization, then I'm just deciding what I want to move, and then I'm moving it across underneath what's existing, and then I can just set myself up for getting that done. If I'm doing horizontal organization, then that means that I'm skipping doing an action layer and I'm just going straight to a rebuild layer. So once again, I cross out the things I'm going to move. But this time, I end up writing the whole thing down horizontally like this. And that way it's nice and neat, and I'm setting myself up for my combining like terms in that way. As I said, personally, when I'm doing math problems, I do this, but when I'm teaching, I often teach this. I do a formula. That being said, I keep it vague. I make sure that I am not being too specific because I don't want students to get too rigid when it comes to the formula. I want them to just understand this is a general guideline for an order of doing things. So number one is simplify terms, aka make all your terms into simple terms. That means distributing if necessary, whatever you need to do to have only simple terms in your equation. Then I call it the sort. That is the addition or subtraction component to segregate your sides, get the variable terms all on one side, get the constants on the other side. Then we combine like terms, and then finally neutralize the coefficient using multiplication or division. And then, of course, with advanced students, I advise them to verify their answer using substitution. So plug in the number back into the equation to make sure that's the correct number. And then finally, this is my list of manipulations. Notice the last one has a star because I usually only teach that to the advanced students. But my list of manipulations are to add a new term to both sides of the equation. And of course, if the new term is the opposite of an existing term, then they will cancel out. So that's a use of that. Or you can relocate terms using the commutative property, which we just talked about on the last slide. You can multiply or divide all terms by the same value. Now, you can do this to, of course, neutralize a coefficient. You can also do it to neutralize a denominator, in case you don't want to have fractions. Or you can even use it to change the signs of all terms. And so I instruct my students about the myriad ways that they can use this to help make their jobs easier. And then, of course, if we're dealing with exponents and roots, which we eventually do, the last manipulation you can do is to apply a collective exponent or root to each side of the equation. All right, the final thing I'm going to do before I log off is to do an example with you. So here is an example of a pretty complex equation. What am I going to do with this? Well, I don't like fractions. So after I split my workspace, the very first thing I'm going to do is I'm going to neutralize my denominators using multiplication. I can clear both of these fractions by multiplying all my terms by 10. So I'll multiply all three terms by 10, and that will turn this into 30 times 2x minus 5 equals 35x plus 6. Notice I am following that action, rebuild, layering. Now I've got my next action. Well, I guess this would be more of just another rebuild. So I'm doing my distribution. And so I've got that finished. So I've got all my simple terms. And I'm going to move on to my sort. I'll subtract 35 from both sides. Add 150 over here. And I've got 25x equals 156. And then final step, divide both my terms by 25. I'll have to do some long division for this. I'm not going to do it underneath. I'm going to do it off to the side. 156 divided by 25 is 6.2 4. So x equals 6.24. And that's it.